Well, you're gonna know what thousands left. Okay, so it's like. Also, some locations. No, coffee, stuff.
All right, guys.
So where?
We're looking at, gentlemen, I need your side conversations to stop, please. Thank you. So we're looking here, you should have turned in your unit 10 notes packet to 10.3. Okay. So this one printed differently. It's kind of sideways, so you just need to turn your packet sideways when you flip to this page. It was printed landscape instead of portrait, but stop the side conversations. All right. So 10.3 is covering basic trig ratios. Trig is short for trigonometry. So trig is what we're going to use to set up ratios when we have right triangles. We learned Pythagorean theorem last unit, or we reviewed Pythagorean theorem, I should say. But Pythagorean theorem only helps you find a missing side of a right triangle if you know the other two sides. With trig, we can find the missing side if we only know one side and an angle, or we can find missing angles if we know two sides. So you're able to find more parts of your right triangle with trig than with Pythagorean theorem alone. So we're going to start here on the left side. Okay, so you can see it says SOH. I'm going to zoom out a little so we can see this all at once. Okay, so on the left side, it says SOH. Okay, so we're going to pronounce that so. And then CAH is going to be pronounced ka. And then on the back, you'll see, if I can see it, TOA, which we're going to say TOA. Okay, so you may recognize this from geometry. I'm going to put it all together at the top. SOHCAHTOA. Okay, this is a memory tool. This is just a mnemonic, like a phrase to help you remember your trig ratios. So we'll talk about what it stands for here in just a second. I'm going to write it all together at the top. SOHCAHTOA. Does that sound somewhat familiar to y'all? SOHCAHTOA? Okay, you should have learned this in geometry last year or 2 years ago whenever you took geometry. SOHCAHTOA, the S, the C, and the T stand for the different trig operations. So the S is for sine. Okay, sine is the first trig operation we're going to look at. Okay, so sine is the ratio of the length of the opposite side to the length of the hypotenuse. And we talked about that word hypotenuse when we did Pythagorean theorem. Remember, the hypotenuse is across from the 90-degree angle. Okay, so in this image, in this example down here, we need to mark B is the 90-degree angle here. So across from it is the hypotenuse. So I'm going to label it, I'll just say HYP, short for hypotenuse. Now, depending on what angle you are measuring from, the opposite side is going to change. Okay, this 3 is opposite angle C, isn't it? And the 4 is opposite angle A. So we need to know angle A or angle C as our reference before we know what side is opposite. So you can see I've written both ratios here for you to have from angle A or is opposite. So from angle A, the opposite side is 4. So when we say the ratio of opposite to hypotenuse, okay, and that's what the OH and so is, sine is opposite over hypotenuse. That's what so stands for. So the opposite of side A is 4. The hypotenuse does not change. Okay, so the hypotenuse is going to be 5 no matter what. Okay, but then if we were measuring from angle C, opposite of angle C is 3. So if we were asked for the sine of C, our opposite side would be 3. The hypotenuse is still 5. The hypotenuse doesn't change. Okay, it's always across from the 90-degree angle. So that's going to be the denominator in both of these. Now, the angle that you put here, notice it's A or C. Notice we don't have sine of B. Okay, you do not take the trig value of a right angle. It's got to be one of the acute angles, one of the angles that's less than 90 in the triangle. Okay, so you do not take sine of a right angle. So you're never, in this case, in this image, you would never have sine of B. Okay, because across from B is the hypotenuse. That side can't be the opposite and the hypotenuse. That doesn't work. Okay, and that's it. You just leave it as this ratio. Okay, if you're asked to write it as a decimal, you could type this in and get it as a decimal, but I'm not going to have you do that. We're just going to leave it as ratios, as fractions. If you wanted to say, if you want to write it down, you can. This would be 3/5 would be 0.6 and 4/5 would be 0.8. And you would just get that from your calculator. But we're typically just going to leave it as a ratio, a fraction. Okay. All right, so let's try and apply that for sine. Okay, we want to set up the sine ratio for the given triangles. Okay, so the first thing I'm going to do is I'm going to label the hypotenuse. My hypotenuse is across from the 90-degree angle. So that's 13. And I know SOHCAHTOA is always O over H. So H is going to be the denominator, which in this case is 13. It doesn't matter which acute angle we're measuring from, that's not going to change. Now, which angle are we never going to do sine from? That's going to be the X. See, we can do sine from angle Y, and we can do sine from angle W, but not X, because X is the 90-degree angle. Okay, so angle X, we're not going to have a sine ratio for. Okay, now I'm going to pick one of those acute angles and identify what's opposite of it, which in this case is 12. So from angle W, the opposite side is a 12. So 12 over 13 is sine of W. If we were going from angle Y, opposite of angle Y is 5. So it would be 5 over 13. And I'm not going to bother writing those as decimals because I would have to round. So I'm just going to leave those just like that. So sine of Y is 5/13. Sine of W is 12/13. We will not have sine of X because X is the 90-degree angle. Okay, let's try this here. What is the 90-degree angle here? The R, S, or T? So R will never have sine of angle R, because angle R is the 90-degree angle. Okay, opposite of angle R is our hypotenuse. Okay, that's going to be 25. So that's going to be our denominator, because it's always, the hypotenuse is the denominator for sine. Now, I'm going to pick one of the angles. I'll just pick S to start. So sine of angle S, opposite it is 24. So 24 over 25 is sine of angle S. If I measured from angle T, opposite angle T is 7. So opposite sine of T would be 7 over 25. Sine of T equals 7 over 25. You don't have to write the OH every time when you start doing this in your practice. That's just for the sake of our notes. I want you to put S for sine is O over H. That's the SO part of SOHCAHTOA. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So far, so good? Okay, the second part of that phrase, so CAHTOA, is the CA, the C-A-H. That C stands for cosine. The H is still the hypotenuse. So cosine is the ratio of the adjacent. A stands for adjacent to the length of the hypotenuse. So H is still our denominator. See, it's adjacent over hypotenuse. If you need to put for adjacent, that means next to. So it's the leg next to that angle, adjacent to that angle, not opposite it, but actually touching it, the leg that touches that angle. So again, my hypotenuse is the denominator. Okay, it's across from the 90-degree angle. That's the hypotenuse still. Okay, now this time when I measure from angle, color code this correctly, angle A, I want to know what's adjacent to it. Adjacent means next to. So A is where the hypotenuse, which is 5, and this leg, which is 3, meet. So this is next to, adjacent to leg 3. Okay, angle C is the side that's 4. Okay, and this is cosine. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So let's try and apply this. And actually, I'll put the decimal here for these because they do come out. So this one would be 0.6 and this one would be 0.8. Do you notice how those are opposite of what the sine were? Sine from angle A is the same as cosine from angle C. Sine of angle C is the same as cosine of angle A. So sine and cosine have this relationship where sine from one angle is the same as cosine from the other angle. Y'all see that? We got 0.8 there and there. And we got 0.6 here and here. All right, let's label. Okay, what is the hypotenuse here? 13 is the hypotenuse. Very good. So that's going to be my denominator for sure, because hypotenuse is always the denominator if it's being used in our 3 trig ratios. Okay, cosine is adjacent. over hypotenuse. Okay, so I want the adjacent side, oops, I circled angle W first, so I'll do W first. Adjacent to W is this leg that's 5. So adjacent to W is the 5. Adjacent to Y is 12. So again, it matters which of the acute angles you're measuring from when you get your ratio. Cosine of Y is not the same as cosine of W because they're adjacent to different angle or different sides. Okay, now which one are you never going to take cosine of? Again, that's the right angle. So in this case, that's angle X. So you can again see when we did this triangle with sine of angle W is the same as cosine of angle Y, 12/13. Sine of angle Y is the same as cosine of angle W. Okay, so if you switch the angle, okay, it's going to be the same as the other trig function, sine versus cosine. All right, last but not least, the hypotenuse didn't change, still 25. So hypotenuse is the denominator. Okay, now if I measure from angle E, adjacent to E is the 7. If I measure from angle F, adjacent to F is the 24. And you can again see that relationship between sine versus cosine for this triangle. And you will never have cosine of angle D here because that's the right angle. So far, okay with sine and cosine? Or SOHCAHTOA. So sine O over H, cosine A over H, and then the last one is the TOA. That T stands for tangent. This is the last trig function or trig ratio we're going to look at. So tangent. Okay, tangent is now the ratio between the two sides we haven't paired together. We paired opposite and hypotenuse. We paired adjacent and hypotenuse. Now we're going to pair opposite and adjacent. Okay, so it is the ratio of the length of the side opposite the angle to the length, and I guess I should put leg there, not just side. Make sure you know that the side opposite the angle, we're talking about a leg. It cannot be the hypotenuse. Okay, so the leg opposite the angle and the leg adjacent to the angle. So same first triangle, B is the 90-degree angle. So this is the hypotenuse. We're not going to use hypotenuse. 5 is not going to be part of any of these ratios because hypotenuse is not part of the tangent ratio. It is opposite over adjacent, hence TOA. Tangent is O over A. So we have to decide from angle A, this is opposite, this is adjacent. So that would be 4/3. So from angle A, we get 4 over 3. But if we measure from angle C, the 3 is now the opposite and 4 is now the adjacent. So you get 3 over 4 if you go from the other angle. So do you see how they're just the reciprocal? You just flipped the fraction if you went from the other angle. So you have to know the angle you're measuring from. because from there, you label the opposite side, which is across the triangle, and you label the adjacent side, okay, what it's next to, the leg that it's next to. Okay, you're never going to take the tangent of the right angle. Okay, so what's the right angle here in this one? The X, so you will not take tangent of angle X, that's for sure. Okay, your hypotenuse is 13, no matter which of the acute angles you're measuring from. Let's start with W. Okay, so the tangent from angle W, remember it's opposite over adjacent. So opposite is 12, adjacent is 5. Now, if we were to measure tangent from angle Y, opposite of Y is 5, adjacent to Y is 12. So it's flipped, 5/12 versus 12/5. You will not be able to give tangent from angle X because X is the right angle. Okay? They might want you here, now that I look at this, they have the segment name here instead of O over A. So if we put the segment names here, let me do that real fast. Oops, that was supposed to be an eraser. So from angle Y, the opposite side was segment XW. The adjacent side was XY. But when I switched the angle I'm measuring from W, XY is the opposite and XW is the adjacent. So if you prefer to put the segment name there for your notes instead, you can do that as well. I think that might have been what they were intending. All right, so I'm gonna do this last one, and then when we come back from lunch, we'll do these application over here, or these problems on the right. Okay, so I'm just gonna finish this video here. When y'all come back, I'll go over it with you. So 90 degrees is P, so there will be no tangent from angle P. Okay, so 25 is the hypotenuse, so 25 should not be a part of any of your tangent ratios. Okay, because tangent this is angle Q down here. Opposite of angle Q is 24, which if you want to name it, that's PR. Adjacent to it is the 7, which is side PQ. But if I switch and I measure from angle R, now 7 is the opposite and 24 is the adjacent. All right, so I'm going to stop that video here.